what CAPM and market efficiency say is that this market factor is so strong that it completely explains the variation of your stock's excess return, so that the alpha will always be equal to 0. Market efficiency says as long as CAPM is correct, as long as CAPM is your correct asset pricing model, you have to have 0 alpha, so that it explains everything. Your market factor explains everything. Then what happens? I mean, even before that, what you have? Now send this risk-free rate to the other side of the equation, so that your return will be RF plus beta I RM minus RF. Okay? And plus, of course, there will be alpha plus something called epsilon. Okay? I said this alpha will be 0. Okay? If you read carefully in the homework note, you will see that this one has to do with the CEO's ability or their performance. And some of you question that, isn't this alpha equal to idiosyncratic risk? And the answer is no. Okay? I wrote down here something called epsilon. Okay? What is that epsilon? Well, that has to do with this guy over here. You pick any one point over here in your sample data, and then see where it stands in terms of Rm minus Rf, your explanatory variable, and then you can figure out what has to be your predicted value of Ri minus Rf over here. This is a predicted value, Ri minus Rf hat, I would say. Then there comes a difference between these two. The predicted value versus realized value. There's a difference. Okay? This point says everything is explained, completely explained by the market factor. Systematic risk explains this part. And there is a part of the return that is not explained by the market. That's the residual part, epsilon, tanta. Okay, tanta part. Okay? And then this part, it has to do with your idiosyncratic risk, firm-specific risk. Something that is not really explained by the market. So idiosyncratic risk should be standard deviation of epsilon. You see epsilon plus, epsilon minus, all different epsilons. You see that? Epsilon plus, epsilon minus, epsilon 0, going on. Okay? There should be some standard deviation of this epsilon. Okay? How dispersed is it? That is something called idiosyncratic risk. Something not explained by the market factor. Okay? The systematic risk. So that is this part. Okay? Now this is CAPM. Okay? And then because realistically in practice, because it is very tedious to subtract this risk-free rate, risk-free return at each time, we just forget about this RF part and then run a regression of Ri against Rm only, this guy. You get almost the same beta. Not exactly the same beta as CAPM, but almost the same. Okay? And then the R squared of this regression provides an estimate of the proportion, the risk of a firm that can be attributed to market risk. And then 1 minus R squared will be telling you about how much is not explained by the market, how much is coming from the firm-specific risk. So 1 minus R squared, is that exactly the same as this guy? And the answer is no, no, no. It's just a proxy for how big this is. Okay? 1 minus R squared is correlated with your idiosyncratic risk. The most precise idiosyncratic risk measure is that guy, by the way. That's it. Decide on the estimation period. To run a regression and things like this, we're going to come back on